Hi guys. Okay, today we're going to talk about types of sampling and bias. So the first thing you have to realize in statistics, you need to understand the difference between a population and a sample. Now, the population is the entire group that you want to draw conclusions about. They're the target of your research, everybody that you want to know about. However, it's really hard to test and survey everyone in a population. That's why we take a sample. So a sample is the specific group of individuals that you will collect data from. So the population can be defined in terms of the geographical location, a specific age group, an income, or all other kinds of things. So it could be all the adults in the United States. It could be all the people between the ages of 12 and 18, whatever your population might be. Okay, but the population is really, really large, so we take a smaller group called a sample, and that's the group that we survey and we look at. So for instance, of the US adult population, 36% have an allergy. A sample of 1,200 randomly selected adults resulted in 33.2% reporting an allergy. Now the population in here is US adults. That's everybody that was targeted. The US adults. The sample would be the 1,200 randomly selected adults. Now, like I was saying, the reason we take samples is because it's usually too hard to interview an entire population. That's what we call a census. And last year we had the census done, and it was really hard to get everybody even to respond to that. It's really hard to test everybody, okay? Now, when we try to gather data, there's good ways to get data and there's bad ways to get data. So let's look at some good ways. All right, so the first method of sampling that we can use is something called a simple random sampling, which is almost always abbreviated SRS for simple random sampling. In a simple random sample, every member of the population has an equal chance of being selected. This is usually done by numbering every person in the population and then randomly selecting the numbers. It can be done with a technology and a random number generator. It can be done by putting names in a hat and pulling them out, whatever it takes. Now, so here's again the population, and we're just randomly picking certain people out. That's a simple random sampling. Let's look at a specific example. And we're going to keep this theme as we go through all the other types. Let's say we want to determine favorite ice cream flavor of the students at Farmingdale High School. So our population is the students of Farmingdale High School. All, what are we, 1800, 17 something? Somewhere between 1700 and 2000. I'm not sure the exact number. Okay, so if we're going to do an SRS, okay, a simple random sample, one way we could do that is we number an alphabetical list of all the students and then randomly select 400 students and interview them or survey. So every one of the students is assigned a number, and then maybe we use a random number generator and we pick 400 numbers out of that. That would be our simple random sampling. Now the next one is systematic sampling. So systematic sampling is similar to simple random sampling, but it's usually slightly easier to conduct. Every member of the population is listed with a number. But instead of randomly generating numbers, individuals are chosen at regular intervals. That means we say every nth person, maybe every 6 people we're going to survey, or every 10 people we're going to survey. But there's a catch. You must start at a random spot. So for instance, in this picture, we started at the second person, and then we went every 1, 2, 3 people, we surveyed again. 1, 2, 3 people, we surveyed again. 1, 2, 3 people, we surveyed again. 1, 2, 3 people. So here, every third person was surveyed in that picture. So let's go back to our ice cream example. So in our ice cream example, let's see, we'll write this down. From our previous list of numbered Farmingdale High School students, we pick a random number to start at, and then we interview, say, every 15th student on the list after that. And we might start with the second student, we might start with the 50th student, but once we have that starting place, then every 15 names on the list, that's who we interview. Okay, next comes our stratified sampling. Now, stratified sampling involves dividing the population into subpopulations. So we're going to break them into groups that may differ in important ways. It allows you to draw more precise conclusions by ensuring that every subgroup is accurately represented in the sample. Okay, so to use this sampling method, you divide the population into subgroups, which they're called strata, based on relevant characteristics. So maybe we divide them into males and females, or maybe we divide them into groups from 0 to 6, from elementary school age, then middle school age, then high school age, college age. We divide them by ages. Maybe they're divided by income bracket, or their role in a job. So if you're looking at a business, maybe it's the management is kept separate from the regular employees. You're going to break them up that way. You're definitely going to make your subgroups. If we go back to our ice cream example, there's at least 2 ways we could do this. Let's say we separate the students by biological sex, and then interview 50 students from each subpopulation. Okay, so everybody's split into the 2 groups of whether by biology they're male or biology they're female, and then we take 50 from each of those groups and survey them that way. Another way would be to separate the students by graduating class, and I like this one better. So we separate them into freshmen, sophomore, juniors, and seniors, and then interview, and we pick some number. Let's say interview 50 students in each grade. And it doesn't have to be 50. We could say, oh, we're going to survey 25 in each grade, or we're going to survey 80 in each grade, whatever we decide to do. Okay? That would be a stratified sampling. So the stratified sampling, they're divided into groups where everybody in this group is the same and everybody in this group is the same by some characteristic. They're not all identical, but whatever common characteristic they have. And then you survey those groups. Now the next one is what we call cluster sampling. Now cluster sampling also involves dividing the population into subgroups. Okay, so breaking it into smaller groups. But this time, each subgroup should have similar characteristics to the whole sample. So instead of sampling individuals from each subgroup, you randomly select an entire subgroup. So if you look at the picture over here, each of these little clusters or groups is similar to the whole in general. So they have the characteristics of the whole population just broken up, and then you take a couple of those clusters to survey. Now, if it's practically possible, you must include every individual from each sampled cluster. If the clusters themselves are large, you can also sample individuals from within each cluster using the stratified sampling or the SRS. So now, how is this method different from the stratified sampling? The difference is your subgroups are heterogeneous. They're all mixed up. Whereas in the stratified sampling, they were homogeneous. Everybody had the same characteristics. Here, we're heterogeneous. Everybody has different characteristics. It's like each one is a mini version of the entire population. I like that, the mini version of the entire population. So how could we do that in our ice cream survey? One way we could do that would be to randomly select a lunch period and interview every student that has lunched that period. Now that only works if you include the seniors who go out for lunch. You'd have to grab some seniors before they leave. Okay, so everybody who has a lunch period, not everybody who's in the cafeteria. Okay, so you'd have to randomly select a lunch period and interview every student that has a lunch that period, not everybody that's in the cafeteria. Okay, so that's cluster sampling. Now there's something called convenience sampling. And convenience is exactly what it sounds like. Asking people about their favorite grocery store in front of a grocery store. That's a convenience sample. Okay, but if you think about that, there's some problems with that. If you're surveying people about their favorite grocery store and you're standing in front of a grocery store, odds are they're going to say that grocery store is their favorite store. Okay, that's an issue because you see, a good sample is representative. That means that each sample point represents the attributes of a known number of population elements. Okay, and convenience sample often has what we call bias. And bias often occurs when the survey sample does not accurately represent the entire population. And I do mean the entire population. So the bias that results from an unrepresentative sample, like standing in front of the grocery store, is called selection bias. So there was selection bias in that grocery store example because we were already standing in front of a grocery store. And most convenience samples are terribly biased, okay? Most convenience samples are terribly biased. Let's look at some common examples of selection bias. One would be undercoverage. So undercoverage, kind of what it sounds like. One or more parts of the population is less represented than other parts. So if you're standing in front of Stop and Shop's customers are represented there, but ShopRite's customers are not really represented in the same way. If a radio station is asking what your favorite type of music is, but they're a country music station, you're probably going to get a lot of people that say country music is their favorite. And that's not really going to be representative of everybody because I'm pretty sure most of you, country music isn't your favorite music. The next one would be a non-response bias. A non-response bias, that's when people fail to respond for whatever reason. Either they're unable or they're unwilling to participate. So if you're not getting enough responses, that's a non-response bias. The next one is a voluntary response bias. And that's when people have to volunteer to respond. When people volunteer, okay, that's a bias. Think about this. If you have a call-in radio show and they're talking about a controversial topic, abortion, affirmative action, gun control, anything like that, any of those hot button topics. Only certain people are going to call in that radio show to talk about it. You're going to have the people at the extreme ends, the big loudmouths, the really, really, at both extreme ends of those issues. You're not going to have the average Joe picking up the phone and responding to that because they don't want to get in the middle of this argument. They don't want to make the time to call that. They're driving in the car. They're not dialing the phone. That's a voluntary response bias because only the people who have the time, who have the willingness to put themselves out there on a hot button topic, they're the only ones calling. That doesn't make it representative of everyone in your population. Also, there's something called a response bias. That's when people are influenced to respond a certain way. That's when you're asked leading questions. Okay? Questions should be framed to have a neutral tone. Whoever you're asking the question of should not know what your opinion is. They shouldn't know which answer you want them to have. If they sense what you want the answer to be, you have a response bias in your survey question. For instance, since 18-year-olds are old enough to be drafted and fight in a war, do you think it's fair that the drinking age is 21? That's a leading question. You've biased the response by framing the question in that way. A better question would be, do you think the drinking age should be 21? There's no lead in there. There's no bias in it. It's a very simple, there's no tone, as in it should be a positive response or a negative response. There's a neutral tone to that. And one more thing that I want to talk about is there's a very common misconception that if you have a set of data that is biased, okay, for instance, a response bias, you can do something to fix it. A lot of people think that if you just get more data, you get more answers, then there'll be less bias. That's not true. It is totally false. You just have a bigger biased sample. So if you're taking your survey, if your survey is bad, if your sampling of a population is bad, using more people in that is not going to make it better. It's just going to make a bigger bad survey. Okay? So you have to be very careful in how you frame your questions, how you put your questions out there, and how people are going to be able to respond to them. Okay, guys, so this was an introduction to our types of samplings and bias. See you soon. Bye.